So, what is mixing? Mixing is basically a process of thoroughly combining the different materials to produce a homogeneous mix. That is the main function of mixing. And why is mixing important? The purpose that mixing is important, I would like to kind of relate to some examples that all of us in our day-to-day life experience. Let us look at the pharmaceutical industry. Now, in the pharmaceutical industry, it is extremely important to have the right formulation of the active ingredient in the entire process, in the entire mass. Because that is what is going to be responsible for the effect that the drug is going to have. And if the proportions are not right, if the concentrations are not right, the effects of that could be very disastrous. A more common process, but equally critical, is in the construction industry. When we mix sand with cement, and have some other materials for giving some properties. Again, if the mix is not right, we can have plenty of challenges and plenty of problems. So mixing in any application is a very critical process, because the mechanical properties, the chemical properties, certain cases, the texture, in food products it could be the flavor, in certain cases it could be the composition. That is defined by the quality of the mix. Don't get your mix right, every other process thereafter, like you did mention, that the percent of rejection is high, and that can be very expensive. So, rejections and poor mixing. What do we mean by a product which is not well mixed, or which is poorly mixed? It is something which is non-homogeneous, and non-homogeneity could be with respect to a particular parameter. It could be with respect to lacking consistency in the chemical composition. It could be color, flavor, reactivity. So it is extremely important that at the end of the mix cycle, what we get is homogeneous. There is also a difference in the extent of homogeneity when it comes to solid mixing and liquid mixing. Because in liquid mixing, when you draw a sample, the level of homogeneity that you get is far greater than what you would get in what is defined as a well mixed solid sample. Because depending on the blend structures, depending on the material properties, the levels of acceptance in the case of solid blending are less as compared to what is expected in the liquids. So again, the non-homogeneity, what it could lead to? It could lead to a lot of failed batches. It could lead to a loss of high value product. The chemical industry, the pharmaceutical industry, we all have experiences on what a cost of batch could be. And one bad batch could cost quite a bit. So it is estimated that the cost of poor mixing, this is some data which has been pulled out from the Handbook of Industrial Mixing, that the cost of poor mixing is estimated at US dollars 100 million per year. So poor mixing can be very expensive. That is the reason why we need to focus on mixing when it comes to any product formulation or development. What are the reasons for poor mixing? As I said, mixing is a science as well as an art. So not everything is there in the books, and not everything can be done by experience. At times you will have to try and experiment. But the most common reasons for poor mixing is lack of understanding of material characteristics. A lot of times, as equipment manufacturers, we get inquiries, please quote for a mixer of such and such capacity. Okay. The type of mixer is this. And that is not enough. That is not enough. Because it is not like a kitchen mixer where you can probably put in whatever you want and get whatever you want. No. You have to be very, very specific on the material characteristics. Like you could have materials like solid powders, which are very, very heavy. You could have materials like waste that can have its own challenges, and you can have materials for coating. So the thing is that the same mixer may be used for all of these three applications, but the three applications are very, very diverse. So understanding the material characteristics is the most important thing before we start looking into any mixing challenge. The other thing is that the mixing objectives are not well defined. What is the end point of mix? What are we trying to achieve? What is our desired state? A lot of times that is not accurately defined, and again it is somewhere due to lack of understanding of the product or the characteristics. A lot of times incorrect selection of mixer. I mean that's the tool. That's the tool which is going to convert your raw material into a finished product. It is very, very important that the selection of the mixer is done taking into consideration the material properties. We will look into how what are the factors which get into the mixer selection. A lot of times, and it happens in the industry, is that a new product has been developed and it needs to be produced. There is a sudden demand. The customer wants the product to be made. Okay, what is the equipment that we have? We have these equipment. Okay, I think this will fit in. Let's try out the process of this. It happens. It happens. So whether that equipment is suitable for the process or not is first to be evaluated. Only then we can be sure about the results. Wrong scale-up techniques. When it comes to applications where you don't have much of a background, much of anything which has been studied, it could again be a challenge to develop a production size mixer. So you would have to conduct laboratory trials. Take the results from a laboratory trial, bring it to scale up. I will share with you as we move forward an example where how expensive can something like this be, an incorrect scale up. And definitely we all need to update ourselves on knowledge of mixing equipment design. What would be the capabilities of a particular kind of a mixer, what would be the parameters that would be in mixer selection. So it is nothing which is like complex. No, it is all within this, and so long as we take care of this, we should not have any challenge.